Welcome to this deep dive into the fascinating science of how salt interacts with meat. We're going to explore a paradox. Salt can make meat incredibly tender or surprisingly tough, all depending on timing, concentration, and contact time. Here's the question we need to answer. How can the same substance, sodium chloride, cause completely opposite effects on meat texture? The answer lies in understanding meat structure at the molecular level and how salt interacts with proteins over different timescales. First, let's understand what meat actually is. Meat is primarily composed of muscle fibers, which are long bundles of proteins surrounded by water and connective tissue. Muscle fibers are composed of about 70% water and 20% protein, primarily myosin and actin. These proteins are arranged in long chains that can contract and relax. The proteins in meat are held together by several types of bonds: ionic bonds, hydrogen bonds, and disulfide bridges. These bonds determine the structure and texture of the meat. Now let's explore the first effect: how early brining creates tenderness. When you submerge meat in a salt solution for several hours, something remarkable happens. What happens during brining? The salt dissolves in water and dissociates into sodium ions and chloride ions. These ions then penetrate the meat tissue. Salt dissociates into sodium-positive ions and chloride-negative ions. Step 1. Salt ions begin to penetrate the meat surface through diffusion. This process is driven by the concentration gradient between the brine and the meat. Step 2. These ions get between the protein molecules and disrupt the electrostatic interactions that hold the proteins tightly together. The sodium and chloride ions insert themselves between protein strands, pushing them apart and weakening the bonds that hold them together. Step 3. As the salt concentration increases, the proteins begin to denature. This means they unwind from their tightly coiled structure. Step 4. Here's the magic. Once the proteins unwind, they expose hydrophilic regions that were previously hidden. These regions attract and bind water molecules. The meat can absorb 10 to 20% more water through brining. This extra water gets trapped within the protein matrix, making the meat juicier and more tender. Let's do some back-of-the-envelope calculations. Say you have a chicken breast weighing 200 grams. Initial mass is 200 grams. You brine it in a 6% salt solution, which is about 60 grams of salt per liter of water, for 4 hours. If the meat gains 15% water, that's 200 times 0.15 equals 30 grams of additional water. Final mass is 230 grams. That's a significant increase that translates directly to juiciness. Now let's explore the opposite effect: how aggressive late salting or curing can make meat tough. This happens when salt is applied heavily just before or during cooking, or during the curing process. Why does late salting toughen meat? The answer is osmosis and dehydration. When you apply salt to the surface of meat just before cooking, you create a very high salt concentration at the surface. Step 1. The high salt concentration on the surface creates an osmotic pressure gradient. Here's a visualization. The salt on the surface has a much higher concentration than inside the meat. This creates a driving force for water to move from inside the meat to the surface. Step 2. Water molecules move from the meat interior, where salt concentration is low, to the surface, where salt concentration is high. This is osmosis in action. Step 3. As water leaves the meat, the protein strands that were spaced apart by water molecules are now pulled closer together. The meat contracts. Step 4. If you're cooking the meat while this is happening, heat accelerates the process. The proteins coagulate and form tight, dense structures. The result is tough, dry meat. So here's the critical question. What's the difference between brining that tenderizes and salting that toughens? The answer is time. With short contact time, less than 30 minutes, you're in the danger zone. Salt draws water out, but doesn't have time to denature proteins and allow reabsorption. The meat loses moisture and becomes tough. With medium contact time, 30 minutes to 1 hour, you're in a transition zone. Some tenderizing occurs, but not optimal. With long contact time, 4 hours to 24 hours, you get full brining benefits. Proteins denature, restructure, and absorb water. The meat becomes tender and juicy. The concentration also matters enormously. A typical brine is 3 to 6% salt by weight. A curing salt can be 15 to 25%, or even higher. Let's compare a brine versus a cure with some numbers. Here's a comparison table. A brine uses 3 to 6% salt for 4 to 12 hours and creates tenderness. Dry salting with pure salt for under 30 minutes makes meat tough. A cure uses 15 to 25% salt for days to weeks and creates a firm, preserved texture. Curing is a special case worth examining. In curing, we're not trying to make meat tender, we're trying to preserve it and create a specific texture and flavor. Curing extracts a massive amount of water over time. This inhibits bacterial growth and concentrates flavors. The meat becomes firm, almost leathery, but in a desirable way. Let's consider an example. You're curing a 500-gram pork belly to make bacon. You apply a cure with 20% salt. Initial mass is 500 grams. Over 1 week, the meat might lose 30% of its water. That's 150 grams of water loss. Final mass is 350 grams. The meat is now significantly firmer and more concentrated in flavor. Let's dig deeper into the molecular mechanism. What exactly happens to proteins during salt exposure? Proteins have charged regions along their chains. Positive regions and negative regions attract each other, helping maintain the protein's folded structure. Here's a simplified representation. Positive regions attract negative regions, forming ionic bonds that hold the protein in its compact, folded shape. When salt ions enter the picture, sodium ions are attracted to negative regions, and chloride ions to positive regions. They shield these charges from each other. With charges shielded, the attractive forces weaken. The proteins unfold and relax, exposing interior regions that were previously buried. An important question. How long does it take for salt to penetrate meat? This depends on the size and type of meat. Diffusion follows approximately the square of distance. If it takes 1 hour for salt to penetrate 1 centimeter, it takes 4 hours to penetrate 2 centimeters. Time is proportional to distance squared. Consider a chicken breast 2.5 centimeters thick. For salt to reach the center, it needs to penetrate 1.25 centimeters. Penetration time is approximately 2 to 4 hours for adequate brining effect. Now consider a whole turkey with a diameter of 20 centimeters. Salt needs to penetrate 10 centimeters to the center. The time ratio is 10 divided by 1.25 squared, which equals 64. That means a turkey would need 128 to 256 hours for full penetration. In practice, we brine turkeys for 12 to 24 hours, which gives partial penetration but significant benefit. Temperature also plays a crucial role in how salt affects meat. Let's explore this. Cold temperatures slow down diffusion rates. Salt penetrates more slowly at refrigerator temperatures around 4 degrees Celsius. But this also prevents bacterial growth, which is critical for food safety. Warm temperatures speed up diffusion. At room temperature, around 20 degrees Celsius, salt penetrates faster. But leaving meat at room temperature for hours risks bacterial spoilage. The standard practice is to brine in the refrigerator. This balances adequate diffusion time with food safety. There's a technique called dry brining that cleverly uses both principles. Let me explain how it works. Step 1. Salt is applied directly to the meat surface. The meat is left uncovered in the refrigerator. Step 2. Initially, salt draws moisture out through osmosis. You'll see beads of liquid on the surface after 30 minutes. Step 3. The salt dissolves in this extracted moisture, creating a concentrated brine on the surface. Step 4. Over several hours, typically 8 to 24 hours, this brine is gradually reabsorbed back into the meat through the same diffusion process we discussed earlier. Step 5. As the salty brine penetrates, it denatures proteins and the meat becomes tender, just like wet brining, but without the mess of a liquid brine. The optimal timing for dry brining is 12 to 24 hours. This gives enough time for the full cycle of extraction and reabsorption. How much salt should you use for dry brining? Let's calculate. The target is about 1% salt by weight of meat. This creates the right concentration when redistributed. For a 1 kilogram steak, that's 1,000 times 0.01 equals 10 grams of salt, which is about 2 teaspoons. For a 200-gram chicken breast, that's 2 grams of salt, or about half a teaspoon. Does the type of salt matter? Chemically, all salt is sodium chloride, but there are practical differences. Table salt has fine crystals and dissolves quickly. It's often iodized. Use the calculated amount as is. Kosher salt has coarse crystals and is less dense by volume. 1 tablespoon of kosher salt weighs less than 1 tablespoon of table salt. Sea salt has variable crystal size and contains trace minerals that can affect flavor but not the fundamental brining chemistry. Always measure salt by weight, not volume, for consistency in your results. Let's discuss common mistakes people make with salt and meat. Mistake number 1. Salting meat just 10 to 20 minutes before cooking. This is the worst timing. Salt draws water out but doesn't have time to be reabsorbed. Result: tough, dry meat. Mistake number 2. Over-brining. Leaving meat in brine for too long, especially in high concentration, can make it overly salty and mushy. The proteins break down too much. Mistake number 3. Not rinsing after wet brining. The surface will be too salty. Always rinse and pat dry. Mistake number 4. Using too much salt in dry brining. More is not better. Stick to about 1% by weight. There's an advanced technique called equilibrium brining that gives you perfect control. Let me explain. In traditional brining, you use excess salt solution. The meat can absorb salt indefinitely, making timing critical. In equilibrium brining, you calculate the exact amount of salt needed for your target concentration, considering both meat and water weight. The beauty is that the meat physically cannot become oversalted. Once all the salt is distributed evenly, the process stops. Let's say you want a final salt concentration of 1%. You have 1 kilogram of meat and you use 1 liter of water. Total mass is 1,000 grams of meat plus 1,000 grams of water equals 2,000 grams. Salt needed is 2,000 times 0.01 equals 20 grams. You dissolve exactly 20 grams of salt in the water. After equilibration, which takes about 12 to 24 hours, everything, the meat and the surrounding liquid, will have exactly 1% salt concentration. Why does all this science matter for actual cooking? Let me connect the dots. Brined meat retains significantly more moisture during cooking. The extra water absorbed acts as a buffer against moisture loss from heat. This means you can cook brined meat to slightly higher temperatures without it becoming dry. The extra moisture compensates. Consider chicken breast. Normally, you cook to 74 degrees Celsius internal temperature. With brining, you could go to 77 degrees and still have juicy meat. The texture is also more uniform throughout. The salt helps break down some of the tougher muscle fibers, creating a more consistent bite. Let's summarize and resolve the salt paradox we started with. Short contact time with high concentration causes water loss and toughness. The meat contracts and proteins tighten. Long contact time with moderate concentration causes water gain and tenderness. Proteins denature, unwind, and trap water. Very long contact time with very high concentration causes curing and preservation. Massive water loss, firm texture, extended shelf life. It's all about timing, concentration, and understanding the underlying science of protein behavior and osmosis. Let me leave you with practical guidelines you can use immediately. For tenderizing and juiciness, brine for 4 to 24 hours at 3 to 6% salt concentration. For seasoning only without textural changes, salt immediately before cooking, within 5 minutes. For dry brining, salt 12 to 24 hours before cooking at 1% by weight. Avoid the danger zone of 10 minutes to 2 hours. This is when you get maximum moisture loss without the benefits of protein restructuring.